All right, Harmony Science Academy AP Calculus students, let's go ahead and get into section 3.3. This prompt reads like this. Consider the function on the interval 0 to 2 pi. For each function, A, find the open intervals on which the function is increasing or decreasing. B, apply the first derivative test to identify all the relative extrema and use a graphing utility to confirm your results. Okay, so the calculator, the first derivative test you'll find is going to help you identify relative max and min, and then this section is going to introduce you to identifying increasing or decreasing. Okay, so what else needs to be said here? Implied in here are the critical numbers. Okay, so that is right up your alley because you guys have done this before. Okay, so this first request, right? Find the open interval which the function is increasing or decreasing. Very important is identifying the critical numbers. So how do you do that? You can pause the video and review. Okay, if you have proposed that it is taking that first derivative, good. Okay, and in here you'll see that implied is a second derivative, but that's in our future. Okay, but just kind of giving you the heads up. Okay, so we have f of x sine squared x. Okay, and more importantly, we're working with what? This open interval. Okay, so as far as critical numbers, okay, very important. Whether they explicitly ask for it or not, that's what should come to mind here. Okay, so as you guys know, through looking at a formula chart, the derivative of sine squared x is 2 sine x cosine x. Okay, and the derivative of sine x is what? Cosine x. Okay. All right, and just FYI, I am picking a trigonometry problem. Typically, I pick an easier one. I think this one's pretty easy, but again, it gives us a chance to talk trigonometry, which is something that you guys definitely need a little more practice in, okay? All right, so this seems a little intense, so let's go ahead and simplify it. Factor out a cosine x. So we're working with something a little more simplified here, okay? All right. So where do we proceed from here, okay? As you guys remember, you would set this equal to 0, okay? And you would explore where that happens, okay? I encourage you guys to pause the video here, okay? I know we see it in class one time, but when you watch it on your own, you kind of toe with that, okay? So this would occur at what? X. All right, as far as cosine is concerned, at pi halves and at 3 pi halves. And as far as sine, okay, the way you would set this up, okay, and I'm trying to be as efficient as possible so these videos aren't too long. So you would set this factor here equal to 0, so you'd have basically 2 sine x plus 1 equal to 0. Subtract the 1, you've got negative 1. Divide by 2, you got sine x equals negative half. And where does that happen? Okay. So where do you have sine of x equals to negative half? Okay. That means that your y is negative 1 and your radius is 2. So what should be triggered in your mind is basically those triangles where you have 1, 2, square root of 3, okay? And you have negative when you're going down, so it's here. Okay? And where else? Right here. Okay? So here we've got basically 30 degrees on both of these. And this other one is 60. Okay? Alright. And what else should be said here? So again, I'm not the best artist, but this is 180 degrees, right? Or this is pi, and then you're going 30 degrees more. So this one would basically 7. This is for future reference, 7 pi 6. And this one would be what? 11 pi 6. Okay? Why? Because you guys know that pi is 180 degrees. You divide 180 by 6, you get 30, and that's basically this pi plus 30 more, right? And this one is 30 degrees short of 2 pi, so it's 11 pi 6. Okay, so just kind of review that depending where you guys are at. All right, so as far as this is concerned, we have 7 pi 6 and 11 pi 6. Okay, all right. So now, where do you proceed? Again, great time to pause the video. Okay, make that decision. Okay. If you're thinking this is the time to set that table up, good. Okay. Now, real important is we technically have this interval here. Okay. Plus, we've got to deal with 2 pi, right, which is that open interval max, and then the 0, the min. Okay. So we should organize them in order. So let's go ahead and try this as best as we can. Okay. All right. I hope I don't regret this table here. Okay. Now again, this is trigonometry, so sometimes it's a little more time consuming, but again, the basics are all here, okay? So as far as the intervals, okay, let's see if I can divide this bad boy up here. I'm going to do this. And looks like I got a little extra space there. Alright, something like that. And here's where basically the interval. Okay, and then you've got what the sign, is it positive or negative? Okay, and the conclusion. All right, this should look, you should reference the tables in the reading. Okay, so again, the open interval is from 0 to pi, 0 to 2 pi. So let's go from 0, and the next one is pi halves. And then we keep marching that way, okay? So then the next one goes from pi halves to what? To 7 pi 6. Okay. And then we go 7 pi 6. What's the next one in the list? Is 3 pi halves. 3 pi halves. All the way to 11 pi 6. 11 pi 6. Alright. And your main concern is it consistent with the reading the guidelines? Okay. Don't get caught up in the details. This was again a little more elaborate, but at some point we got to see this trig stuff, right? Okay. So again, here's 0, pi halves, 7 pi halves, and then we have which one is 3 pi halves right here. So we have 11 pi 6 and then 2 pi, okay, or 12 pi 6 right there, okay. So that's the reason for that, or again, if that makes sense, great. If not, just kind of slow down, take a look, okay. All right, so what I'm going to do here is I'm going to, as you guys are going to notice, there's a quick way to pick special values to help you decide if it's a positive or negative, okay. So here's what we're doing, is the derivative with a given value in this interval going to end up being positive, or excuse me, yeah, positive, negative, or equal to 0, okay. So let's go ahead and try some crafty stuff here. Now again, here it's just an opportunity for me to kind of expose you guys again to some trigonometry, okay. So let me see where I can. All right. So basically I've got to find a triangle in there, okay, between 0 and pi halves. Okay, so I won't do each one of those, but I'll do this first one just so you have an idea of where I'm at. Okay, maybe I'll do 2. Okay, so we're here, and between 0 and pi, I'm going to go with pi fourths, which gives me 1 square root of 2 triangle, right? 45, 90, okay? So as far as that's concerned, pay attention to how I'm going to do this quickly here, okay? See if you can keep up. So here I have already the derivative, right? So as far as cosine goes, it's going to be 1 over, so 1 over square root of 2 is positive. Now I look at sine. It's also 1 over square root of 2 times all this stuff in, or once I perform that math, that's a positive. So positive, that's going to give me positive. Okay, I'll do one more, and then I guess you'll just have to trust me here. Okay, so this interval is between pi halves and 7 pi sixths. Okay, so I'm going to go ahead and pick the same situation here, 3 pi fourths. Why? So I can draw this triangle, okay, which is, hopefully it's not too confusing here. I guess we'll leave it there. Okay. So now I have 1 square root of 2, but technically, right, I'm going up, so I'm fine. I'm going left, so this is -1, right? Horizontally, I'm going left, so I have to be careful with my ratios. Okay, so check this out. As far as cosine is concerned, it's x over r, so it's negative over this, so it's a negative. Okay, then this one's going to be a positive. That whole thing's positive. Negative times a positive is a negative. Okay, so that's kind of how that works. So I will continue. All right, I don't want to belabor it, but basically that's how you can come up with these conclusions here. Okay, and based off of the theorem, you're able to conclude here that what? This is increasing since it's positive. This one is decreasing, positive increasing, decreasing, and increasing. Okay? All right. So, where do we go from here? You can pause the video and see if you can fill in the blanks. All right. So, as far as increasing, okay, we're going to go ahead and do it, kind of cheat the system here. Okay. So, as far as, call it C, in terms of intervals that are increasing, okay, we'll go ahead and label them here 1, 2, so I don't have to write more and eat more time up. Okay, so which ones are increasing? Okay, that's going to be 1, 3, and 5. Okay, decreasing, that's going to be 2 and 4. All right, and finally, okay, what is it that we're going to address here? We're going to address the relative extrema, so the relative minima. Okay. Oops. And the relative maxima. Okay. You can kind of pause the video here and kind of see what you would do. Okay. You would definitely look at the theorem. Okay. So let's take a look at these critical values. Let's say these right here, right? Pi halves. So what's happening to the left and to the right of pi halves? Increase, right? And then decrease. So if you think increase and then decrease, that would make it a relative max. Okay, so let's set it up that way. Pi halves, and then we'll get the other coordinate. Okay, now let's go to the other one. We can go in order or this way. Okay, so let's go as far as 3 pi halves. Okay, let's go to 3 pi halves. 3 pi halves right here. What's happening? It's increasing and then decreasing, right? So increasing and then decreasing. Okay, so that is also going to come up in here. Okay, we'll get the y coordinate here in a bit. Let's take a look at the other guy. 7 pi 6. What's happening? Decrease and then increase, so that's going to be a relative minimum. Okay, that was what? 7 pi 6. And our other last one is 11 pi 6. Okay, what's happening to the left? Decrease and then increase, so that's the relative min, and I should switch them. Let me see here. If you caught that, good. If not, I just kind of had them switched around here. So these are the max, uppercase M, and the min, little m. Okay? All right. So that's off of the reading. Now the last thing we want to do is go ahead and evaluate, okay, or get our y coordinate for each corresponding angle measure here. So let's go ahead and do one last one, and then we'll leave it at that, okay? All right. So let's go ahead and get pi halves. We're going to plug it in back into this bad boy, okay? So, all right, hit the wrong button there. So pi halves would now be plugged into this original function here, okay? And you guys know that pi halves is right here. Where's my pen? Okay, so as far as I'll plug that one in, so pi halves here is 1. 1 squared is 1 plus sine of pi halves, so it's 1, so 1 plus 1 is 2. Okay, so we'd have 2 here. I'll fill in the rest, and you guys can kind of pause the video and work them out here. Okay, so 3 pi halves would have been 0, negative 1/4, and the other one I got here was also negative 1/4. Alright guys, appreciate your time. We'll catch you in class.